All right, welcome to the stage, Sebastian Trolli, the moderator for this session.
Thank you very much, Lucian, Carolina, and the IoT World Organization. Whether you're just starting your day, finishing it, or somewhere in between, welcome to IoT World Manufacturing and Supply Chain Day 2025. My name is Sebastian Trolli. I'm the Global Head of Research for the Industrial Automation and Software Practice at Frost & Sullivan, and thank you very much for joining us for this session, Garbage In, Garbage Out, Fixing Industrial Data Before It Hits Your AI Models, sponsored by Atelic. First, tell us who you are and where you are joining from in the chat window. It helps us to know who's in the room. While you get settled, a few housekeeping items. This session runs just under 60 minutes. We will get you out on time. I will introduce our topic and speakers, then move into the discussion. Post your questions in the QA window, not the chat one. This makes them easier to find and more likely to get answered. We will take your questions toward the end, so submit them as we go. No need to wait. We have a question for you. What are some of the most creative ways in which you are using AI in your daily factory operations? We'd love to hear from your experience in the chat window. Throughout the session, we will be launching 2 poll questions. You will have 30 seconds to pick your best option. Please participate, as the overall results will tell us a lot about your daily challenges and expectations around industrial AI and data management. Follow IIoT World on LinkedIn and X for event updates, session highlights, and expert insights. And last but not least, this session wouldn't be possible without our sponsor, Atelic. Thank you for your support. With the housekeeping complete, let's now focus on the session. AI doesn't fix bad data, it amplifies it. On the plant floor, one flawed data stream can cascade into failed AI rollouts, faulty predictions, or even million-dollar supply chain disruptions. The competitive edge is not simply having AI models. It lies in ensuring that data feeding those models is accurate, contextual, and trusted. This session brings together industry leaders and executives tackling the toughest step in industrial AI adoption: how to validate, clean, and structure data before it ever reaches an algorithm. We will explore 4 core themes today. Why data readiness is the biggest predictor of AI success, how frontline context builds trust in AI outputs, which are some of the governance frameworks and architectures for decision-ready industrial data, and last but not least, infrastructure evolution and competitive advantage. I have the pleasure to be joined by 4 leaders who are dealing with this problem on the front lines. Please welcome Romina Guevara. She's the CEO and founder of Expansiva X and former Chief Product and Digital Officer for Mexico and Central America at Michelin. She was named among FinTech Magazine's top 100 women in the sector in 2021, and she was recognized as a top CIO in Mexico twice in 2022 and 2024. Please welcome Dr. Judith Colliwer. She's a senior industry advisor and principal consultant, advanced therapies at Corber Pharma. Judith earned her PhD studying the genetic background of autism. She served as a lead scientist for BSL-2 virus-based projects at Bielefeld University. And since 2019, she advises ATMP manufacturers on digital ecosystem roadmaps and process model data concepts at Corber Pharma Software. Please welcome Douglas Langen, co-founder and CEO of 4D1, a Calgary-based innovator in ultra-precise indoor positioning technology. Douglas has been pioneering geomatics engineer with over 15 years leveraging GPS to revolutionize outdoor automation, and now he applies that expertise to advance indoor industrial productivity. And last but not least, please welcome Dr. Omid Jiveshi, manufacturing advisor at Atelic. Omid is a digital technology leader with more than 15 years of experience and education in industrial software and building technologies. He has extensive experience at large corporations and startups developing IIoT and AI platforms, industrial AI solutions, and ecosystems. With the intro complete, let's now get into the discussion. So let's start with the topic or theme number 1, which is why data readiness is the biggest predictor of AI success. And for this topic, let's start with Romina. Romina, this question is for you. Before scaling an AI model into production, what concrete indicators help us measure data readiness? What should teams look for?
Okay. Hello, good morning, everyone. Thank you very much for having me. And well, this is a great question, Sebastian. When we talk about the scaling an AI model, the real question is not whether the model is ready. It's whether our data is ready, because data readiness is what is going to tell us if our model is going to survive outside the lab. No? And that is the real question. So I would say that the first indicator would be data quality. And data quality, because sometimes we lie to ourselves and we say, yeah, we believe or we think that the data is good, but we don't really know. So the thing is to make sure that the data is really, really ready. So we need to have, I would recommend to have a data quality scorecard with where we are going to put all the important KPIs. For example, completeness, accuracy, consistency, visibility, and then we need to have all of them in green in order to make sure that we have the right data quality. Because if our foundation is a little bit shaky, then the model will be shaky as well. The second indicator, I would say, is stability in our data, because the data that we use for training must reflect the real world. And that means that we need to have low drift between the training and production samples and a good coverage of the edge cases. Because if we train the model with biased or based on biased or incomplete data, then we will fail. The third indicator is data governance and traceability, because we need to know exactly where this data comes from, how it was transformed, and who owns it. And this is the only way that we have to make sure that we will be able to audit, to debug, and to scale it in the future. And last but not least, I would say that the features that we used when we were training our model must be reproducible in production. Because if our offline and online pipelines do not match, then the model will behave unpredictable. So that is very, very important in the end. So data readiness is the difference, in my opinion, between a model that works only in a demo and a model that works in the real world. So we need to make sure that our data is clean, is stable, is governed, and reproducible. And if we do that, then we will have a real strategic advantage and not a risk when we are scaling an AI model.
Thanks so much, Romina. Great question, great answer to the question. Great insights. Appreciate that. And I encourage all the panelists, if you want to jump in and start a discussion on each question, feel free to do that. Absolutely. So now let's go to Omid, right? Omid, the term data readiness gets used loosely, right? So in the age of agentic digital twins, what does it really mean? I mean, data readiness. What does data readiness really mean, right? Clean data, contextual data, or something more cognitive?
I mean, that's a very interesting question, Sebastian. I mean, we are dealing with this every day. So, data cleanness and data readiness has been the topic in the industry for a very, very long time. And for organizations and also for decision makers in the companies, there is a big shift of understanding data readiness and data cleanness from 2015 now to 2030, because a revolution is already going to happen with agentic AI in the industry. So basically, before when we talk about data readiness and data cleanness for organizations and also factories and industries, we only talk about bringing the cleanness to the data and the context to the data. And for most of our clients, it was always nice to have and not something must to have, because then they said, okay, data is clean, data scientists will take care of this, and then everything is good. But now there is another level of readiness is going to happen based on agentic AI, which we call it cognitive data readiness, where AI agents needs to also work with data. It's not only data scientist and a human being working with data, but now AI agents are getting more and more involved into the systems. And for AI agent, it's a different level of readiness that we expect in the systems to work properly, because AI needs a good data with the readiness and cleanness to reason better and not only correlate like ChatGPT in your daily life. And readiness is, for me, is 3 layers. You have to deal with the physical data, bits and bytes coming from sensors, coming from systems and machines. You have to define them, bring them into the context, and also break many data silos in IT and OT and bring it to the level that AI agent is getting to understand them in a cognitive way. It must encode the cause and effect. It must encode governance, as Romina mentioned. Governance and compliance for data is very important, and trade-offs and intents, because you are not dealing with the human being and operators. You are being dealt with the AI agents, and readiness is not the nice to have anymore. Is really must to have that AI agents are going to, let's say, work properly. Yeah.
I absolutely agree, and thanks for that, Omid, and thanks for making the distinction between a nice to have and a must have right now, right? That's what we also are seeing in our research at Frost & Sullivan. So now let's go to Douglas, right? So Doug, for you, what is the most effective way to improve data quality so AI models accurately reflect what's actually happening on the factory floor?
That's a great question. The most effective way to understand what's actually happening on that shop floor is to physically measure what's happening on the shop floor. There's a lot going on to get a product out the door. And so digitizing the logical flow inside your MES is just the first step. So the real leap comes from reconciling that logical reality with physical reality by using technology like RTLS, real-time location systems, which is what we're in, or vision to capture how the work's actually getting done. So with millimeter level accuracy, every motion of all the tools, parts, robots, and workers enables every task to be QA'd in real time. It also gives AI a classified gold standard ground truth to finally understand the true cause and effect of everything going on the shop floor. So analyzing the shop floor and all of its data in all 4 dimensions is extremely powerful to maximize the signals and context in your data to maximize the robustness of your foundation.
Absolutely, and I agree with that, of course, 100%. Thanks, Douglas. And let's close this first topic, this first theme on data readiness with Judith. Judith, from your work in pharma and biotech, right? What are the risks and costs when data quality falls short? How does this translate to other regulated or high-stakes environments?
I think if we think about the risks and costs, there are always different perspectives to it, right? The first one, specifically in pharma and biotech, I think is pretty clear. If we have poor data quality, and exactly as Romina said, we use a great AI tool on poor data, we will have poor outcome. And obviously, in this case, we will have a direct effect on patients, financial impacts, because either we are in a clinical trial and maybe our clinical trial is on hold. Actually, the FDA published a statement a few months ago that the majority of clinical trials fail because of lack of data integrity. And that is saying something, right? And if we think about the enormous costs that are associated with a clinical trial, of course, first of all, that's massive. But also just knowing that we do have clinical trials specifically nowadays with some new modalities that are solving treatments for diseases that are right now not curable. So we are talking about the fact that patients have to wait longer because we don't do a good job with our data quality. The second aspect to that, I think, is what are the costs associated to cleaning up our data so we are aware that we need to clean up our data, and we do it. I think that's really the favorite one, because we can make an informed decision. We can say, do we know the quality of our data? What does it take us to make better use of it? And what will be the outcome? And I think that is really the most important and most crucial aspect to consider making informed decisions, because no company will change their complete data manufacturing structures from one day to the other. We all do continuous manufacturing. That's just not possible. So I think that is really very relevant. And the third perspective I would like to add specifically for these tightly regulated industries is the costs that are associated to not doing it. So there's so much potential. We have so many data. For example, if we think about basic research, how many labs in the world are doing basic research? All of that is unstructured data. How many clinical trials are executed in a non-structured way and documented in a non-structured way? All of that is lost, and there is such a high risk and cost associated to not cleaning up our data, not making good use of it, and thinking about where we could be if we would do and take this first step. I think that is a very important perspective that we sometimes overlook, specifically in these very risk-averse industries like pharma and biotech.
Thank you so much, Judith, and thank you all for your great insights on this first topic, and I'm sure that the audience is also appreciating them. So we saw that data readiness sets a foundation, right? So the next question is where that data came from and whether people closest to operation trust it, right? So now let's talk about frontline context and trust, which is our second theme or topic of this session today, right? So let's start with Omid now. Omid, operators, you know that operators carry institutional or tacit knowledge that never gets encoded into systems, right? So how can we integrate that frontline expertise into the data validation process for AI?
That's a good one. I mean, if you look at every factory or every industrial system in the world, there are two important elements or two important systems in there. The first one is human, the most important one. Human everywhere, human is the center. And then the second one that a lot of organizations looking at it is the digitization and digital systems to make the efficiency. However, sometimes we are going so far with the systems and technology and digital and forget about the first one and main one, which is human being. I tell you why. I mean, I think with Industry 4.0, with the new revolution of digitization in industry, we look at the technology and connectivity and digitization too much. And we didn't consider human and operators in the industrial systems really a lot. And that was a little bit of technology bias that every organizations are looking like overlooked to that, without considering many years of experience of the human and operators and engineers in the system. And there we kind of going to miss a lot of know-how. I mean, especially in Europe and in some countries, we are going to have a lot of retirement of those people with a lot of experience of years about the system and machines. And this thing is just getting out of the reach, and we are going to waste it. And at some point now, everybody are fascinated about AI. Everybody happy about AI. Let's do AI. But this data in the mind of the people for many years, this know-how and this kind of database that we have is getting really wasted. So what is very important is not really only to look at the data from sensors and IT system and OT systems and other things. We have to really and seriously look at the data from the engineers and know-how of the people in the factories and also in the industrial systems. So if I, for example, make the example of them, there is like a lot of voice-based validations. There are a lot of human in the loop correlations, and a lot of human, for example, know-how that we need to take care of this. And it's already perfectly fine addressed with the next revolution, which is Industry 5.0. They even call it human-centric revolution, because digitization is not the only answer for having most of the data from sensors and machines. We have to seriously look at the information coming from human for the future. And that's how we are also implementing it in our platform, to have AI agents directly working with human, kind of co-pilot in the airplane, for example, and learning from each other. Then AI is kind of, let's say, having really like reactions like real operators in the future, but we are not going to skip the human being with AI. So that's a big mistake, to just skip the human. Human is the center, AI is getting data from human.
Absolutely, Mar. I agree with that approach, and I agree also with the Industry 5.0 concept, right? 5.0 concept of bringing human into the loop. So now let's go to Douglas, right? On this topic, let's continue talking about this frontline context and trust. And Doug, once we trust that our data accurately mirrors the physical world, how does that change the way we identify bottlenecks, train AI, or design the next iteration of a process?
Well, it's kind of like the fog list, because in addition to digital systems and digital data, machines and robots, you can now finally digitize the human element and really capture what's going on in the human world. And so now together you can finally reveal bottlenecks automatically, hopefully in real time, because the system can observe exactly when and where the process drifts from its ideal path and its impact downstream. So AI models train dramatically faster now and perform more accurately because they're constrained by physical ground truth, spatial ground truth. So their insights actually translate to the floor. Process optimization shifts from periodic review to more of a living control system, which continuously senses and automatically optimizes the motion of every resource on the floor.
Absolutely. Thanks for that, Doug. And let's go now to Judith on this topic, who will bring us the pharma and biotech perspective, right, on the topic. Judith, for pharma or biotech organization just beginning to improve their data management journey, right, what should be the first step? What would you say should be the first steps, and where do you see companies in those sectors stumble early?
So that's a really good question. And I think, honestly speaking, that's a great thing about data. We can always take a first step, right? This is not a yes or no. This is not we need to do everything or nothing makes sense. Data really give us a lot of potential where we can take it as isolated steps and take one step after the other. And that is our amazing potential in this area. That is really, really good, right? That's helpful to think about this as a journey instead of we need to be here or there in a year, which again is just not possible in these complex processes. So I think the first step always should be taking a good hard look to what we have today. For example, when it comes to our master data, do we have harmonized master data over all of the different processes, or are they also using silos? When it comes to our data flows, same question. Usually we optimize processes individually, which makes sense, right? Because 10, 20 years ago, when these processes were maybe established and developed, we wanted to optimize our process. We were thinking about the next step back then. Now, we probably need to take a look at how diverse are they, where are we harmonized and where are we not harmonized yet. And then comparing that with the end in mind, if we think about pharma or biotech or cell and gene therapy manufacturing shop floor, of course, we have a highly complex system. If we only consider that as, let's say, an end-in-mind digital twin of our complete shop floor with everything that we are executing, our different processes, but also our supply chain compared to our manufacturing process together with our equipment, what if all of this would be a digital twin? If that is our end-in-mind, then we can take a step back. How would a digital shadow look like? And a digital shadow in a very complex process is already helping us, right? There's already a return on investment. If we take one step further back, if we think about a holistic process that is still maybe having a few manual interactions here or there, how would that look like and what would it do for me? And then we can break that up into individual holistic processes and think, what do we need to do to make use of these individual holistic processes, and what is our starting point. So that's how we usually approach it, and we have made really, really good experience. Another aspect I would like to mention here is very often we tend to jump to the first conclusion, and very often that is, let's start with the most mature process we have, or the one that we execute the most. And maybe that is the right solution, but maybe it's another way that we can take the first step, and that allows us a smoother implementation. For example, when it comes to new modalities, when it comes to the processes that are still in development, they tell us so much, again, when it comes to data, right? Because they introduce process variation, which allows us to introduce process characterization. We can increase our understanding of the process by looking specifically at the more modern, at the most moving targets in our facility. And sometimes that's the best first step. So I think it's always about looking at what we have, comparing it to what we want to have, and really thinking about the first step that will drive us forward, and that also allows us to test, right, to generate data. What was my return on investment when I implemented it in one of my moving targets? I can use these data to make the next investment. I can use these data to make sure that we apply a holistic concept that really works for us specifically. And I think all of these aspects just take the first step in the sense of really thinking about it. Who are we? What do we want to achieve? And how can we get there?
Awesome. Thanks so much, Judith. Great answer. And thank you all for your insights. That's a wonderful way of closing this second theme on frontline context and trust. And now we will have our first poll question for the audience. I'm telling the audience now, please take 30 seconds to respond, and we'll briefly discuss the results. So the question is, what is your organization's biggest barrier to achieving trusted industrial data for AI? Is it siloed data across OT/IT systems? Maybe lack of frontline workers inputting data pipelines? Perhaps no clear ownership of data quality? Is it legacy systems with inconsistent data formats? Maybe insufficient data governance policies? So last 10 seconds to respond, and we will briefly discuss the results. So now let's see the result. Oh, it's pretty, a little bit surprised. I was expecting probably siloed data across OT/IT systems to get a larger share of the questions, of the responses, but 37%. Also, legacy systems with inconsistent data formats, 30% as well, and insufficient data governance policies, 22%. Those are the top three responses. Do you have anything to add? Anything to comment on these results? Romina, Omar, Omid, sorry, Douglas, Judith?
I think that's a very well observation. Still, this problem of IT/OT convergence is getting really for a long time there. And even AI is getting the problem more and more bolder in the future. Yeah. Because of, as I mentioned, like this thing is not really nice to have in the future. It's must to have even to make the things already working. I mean, between IT and OT, interoperability is still getting the most important topic in the future.
I agree.
So the whole thing is about the data silos. Yeah.
And also, I think it was interesting to see that there are 3 front runners, but all of them are interconnected, right? We can't look at one without each other, without looking at the other. If we think about legacy systems, of course, they will have a huge impact on asynchronous harmonization over our IT/OT landscape. So obviously, it will be a topic to address all of them together.
Thank you, Omida and Judith. I agree 100% with your insights, and also thank you, the audience, for answering that first poll question. There will be another in just a few minutes, right? So, going back to the main flow, the main discussion, we saw that trust is essential, right? But it needs guardrails, right? So governance ensures data stays reliable without slowing everything down. So let's explore that balance, right? So now the focus would be governance frameworks and architectures for decision-ready industrial data. So let's start with Romina with this one, right? Romina, how do we design governance frameworks that validate data without delaying decision-making in fast-moving industrial settings?
Well, governance is not a popular topic, or organizations and people usually we don't love the governance process, no? Mainly because the traditional governance slow things down. Why? Because it relies on committees, on manual approvals, on hundreds of approvals. So that's why sometimes governance is not the popular kid on the table. So the thing is that in industrial environments, we need to make decisions really, really fast. So that's why we need to find the right balance between governance and to keep everything safe or to maintain this rigor without creating additional friction. Okay, so in this case, I would say that what we need to do first is to have this governance embedded in our pipeline. We don't want to have extra steps or extra processes. We want to have this inside what we are already doing. So having these automated checks for example, for drift, for validation, for anomalies, then we will have this governance flowing and with at the same time as our data flows. So it's not going to happen after, but at the same time. We can also have what I would call the minimum viable governance, meaning that instead of having 40 different things or 40 different metrics, then we will have only 5 or 7. No? So we don't need to take care of everything. Maybe we just need to pay attention to the most important things. Okay, and maybe we need to have to pay attention to the high risk topics, only that part, and to be careful and rigorous on those ones. But in the rest, we can just leave them as they are, no? As optional, or we just need to take care with automated checks. We don't need to pay attention on that. And the last one is, for example, to have 80% of the process automated and the 20% humanized. If we have 80% of the process automated, we are going to be reviewing everything that we already know, and we're going to leave this 20% only for exceptions, for ethics, for things like that. Now, things that require the input of a human being. If not, the rest need to be automated in the process.
Absolutely, Romina. Thank you for that. Thank you for that answer. And Omid, as AI agents become more autonomous, right? How do we design data frameworks that let them make safe, explainable decisions?
Yeah, that's one of the most important elements that for the next decade, all organizations looking at it, because AI is very young at the moment. Everybody is busy with prototyping and discovering the thing. But then when it comes to the production and serious, let's say, organization runtime, then governance is getting also very important. And today, the traditional governance is just based on human. It's very human-driven, based on the PDF files, based on the Excel files, and a delay of 1 to 2 days or even more. But then if in the future we finally succeed to bring AI agents and AI operators to the industry, then you need a governance for AI operators, which are, let's say, reacting to the commands in milliseconds and not really in weeks. So that's not going to work with this current system. That's really obvious. We need a new system for governance for the future to manage and govern this kind of AI agents, which is also AI based, in my opinion, is a code base. So you need a policy as a code as part of the production system for this agentic platform, as this autonomous platform. You need a continuous decision and risk analysis for AIs to end up with the scary situation that you see in the sci-fi movies at the moment. And also you need kind of I call it AI agentic control center. That's similar to what we have with the security and governance, but not a compliance department of human, which is very slow for AI agents. You need kind of also AI agents to control the AI agents with governance and compliance. And then you can apply this to the other governance systems. But the thing which is already running traditionally is not going to work in the future. That's already obvious.
Yeah. Thanks, Omid. And Judith, one question for you, again, from your pharma and biotech perspective, right? Regulated industries face unique data management challenges, right? So what lessons from pharma and biotech industries apply to manufacturers facing increasing compliance pressure?
I think I would like to emphasize on Omid's point here, the human component. I think that's probably one of the biggest learnings that we also got over the last years whenever it comes to adopting new technologies in, again, a risk-averse, very tightly regulated industry like pharma. Because what we should not forget is that each and everyone who is working in pharma is very aware of the consequences of their decisions, right? That is how they are trained, that is how they are working. So I think what we need to do is making sure that we are delivering tools, using the data that we need to the people who are willing to accept it. And if asked, I think most people, specifically right now, when asked, hey, would you trust rather your own decision or the decision that a tool makes for you? We all trust our own decision because we know if we are sure, if we are not sure, how we came to this conclusion and all of these aspects. On the other hand, if we have supportive tools, if you give me a tool and say, hey, instead of making this decision based on your experience, I will provide you with the data that you need to make a data-driven decision, then I'm all for it, right? So I think taking the human component in mind whenever we choose the tools that we first focus on, then we can make the world of a difference. And when it comes to AI, even with the risk averseness in pharma, we see the industry now really accepting it. And there are a few people or a few companies on the front who are driving the industry forward, which is amazing. That's so great to see because we have always been a little bit more on the conservative side. And now really having some companies in the lead which allow us to develop best practice, which allow us to see this works, maybe this doesn't, so that we as an industry in our consortiums and everything can come together and develop best practices, and with that really support the industry. That is something that we see right now, and I think that is very, very promising. And I think that's completely translatable to every regulated industry because they all face one risk or the other, and they all are aware of what they are doing, and it's part of their identity.
Absolutely. Thanks, Judith. And that's a great way of closing this third theme on governance and infrastructure. So we saw that governance keeps data trustworthy, right? And architecture determines what's possible. Now let's look at where infrastructure and business value intersect. And that opens up to our last topic of discussion, which is infrastructure evolution and competitive advantage, right? So let's start with Douglas here. So Douglas, I have a question for you. With precise spatial data synchronizing people and machines, how do you see collaboration changing across humans, robots, and AI systems? And how will this impact, business?
Yeah, when people, robots, and AI share the same spatial language, they're tied together. They can continuously learn from one another. They can respond instantly to change and work together as a single, well-tuned team. For people, work becomes a lot simpler. It becomes more interactive and accessible to lower skilled labor pools. That, professional kind of context on how does the power user complete their task successfully can be captured and shared. But knowing the exact status of all the human counterparts, the robots gain complete situational awareness, which allows them to react rather than be rigidly programmed. AI can now validate tasks and anticipate what needs to be done in the future, what needs to happen next, enabling more of a shift from individual actors to an integrated system.
Thank you, Douglas. Yeah, absolutely. Absolutely, I agree with that response. And I'm glad to see all the interactions that we are having on the chat window and the Q&A tool as well. So keep placing your messages there. And just in a few minutes, we will start answering the QA from the audience, right? So going back to the topic, now a question for Omid. Omid, there's a lot of focus on model tuning and algorithm selection, right? So why do you believe the next AI advantage lies in agentic data infrastructure instead?
Yeah, that's a good question. I mean, for the moment, we are just getting into the AI era, and a lot of people are just discovering this with LLMs, with technologies, with different APIs and other things. However, when we get into the serious I call it post prototyping era, the people are just facing with the real things in the longer term, which is more data quality, agents efficiency. I mean, how deep is agent is giving the results and outputs and not really scratching the surface for them. Some self-validation, some autonomy. I mean, it's very similar to what happened in the electrical cars with autopilot and autonomous drives. So at the moment, we are just discovering prototyping with the first level of autonomy. But if the organizations are getting really into this journey to get more and more deeper, you have to have a very good database. I mean, not database, but databases. I mean, data quality, context, self-validating, and optimization to go into the more and more levels of autonomy. And that thing is not really related to the models and LLMs and APIs and vendors and technology. These are just enablers. But as much as you have a good data quality and data readiness, you can unlock more and more values of the autonomy with the systems. And that's really depending on the quality of data in terms of context, in terms of self-description, and in terms of a good relationship with the AI agents to get the data and getting the output out of the systems. So if this thing is happening with a good quality, then organizations are able to bring them into the production successfully and getting the better business efficiency and ROI accordingly. I hope I answered this in a short.
Absolutely. Thanks for that, Omid. And to close this topic, one final question for Judith this time. Again, from your pharma and biotech perspective, right? What are the most promising AI use cases that you see in pharma manufacturing today? And what data infrastructure do they require to achieve a competitive advantage?
I think what we really see right now, specifically in manufacturing, are probably the ones that we see in other industries as well. For example, predictive maintenance, where we just have massive amount of data. It can collect our low-hanging fruits to just support the decisions again that we have to make. Or when it comes to collecting our historian data to optimize our process. These are the things that right now a lot of people are focusing on, and we definitely see a good step forward with the industry, and we see the enormous potential. And I think here, comparably, the changes are small that we have to make when it comes to, again, harmonization of the processes, but also really thinking, which data do I really need that my tool can provide to me? For example, my MES system can probably provide the recipe data that I need to contextualize the result data of my manufacturing process, but I need to collect it, and I need to make sure that I use them, and that I use them in the right way, and that I harmonize, ideally, my processes over different implementations so that I can make them comparable, include training data, include, again, clinical trial data, engineering runs, because they, again, introduce data variation that we can really use for our advantage. Specifically in pharma and medical, we do have a few things that are not as clear and maybe not the first one we think of, but that have incredible potential. For example, when it comes to real-world data, that's really the most powerful set of data we can think of in pharma, because it tells us basically our medical data in clinical trial surveys that the patients fill out. They are so powerful, but they are per definition unstructured because they are based on surveys, they are based on what the physicians tells us. And implementing processes that allow us to structure these data is really not that difficult, because it means we need to adapt our surveys, we need to adapt the tools that the physicians use slightly here or there, but there's such an unused potential in using that. That is something that we really see right now. And maybe the last aspect that, again, is very promising because it's just an unmet need, is in the diagnostic part, for example, when it comes to rare diseases. The recognition rate of rare diseases is still so low because obviously no physician can know all diseases. That's not possible. But the results that we have seen in models or in early adopters of using AI to suggest rare diseases based on symptoms is incredible. And that is really where we can change everything that we are doing based on starting to use it. And here, of course, we are talking about end users, the physicians. So we really talk about how can we develop procedures that allow everybody to use that to make this potential possible. So that is, I think, with the real world data, the two things that I hope we will focus on more in the future than we do right now.
Thank you, Judith. Thank you, as always, bringing us your perspective on the pharma and biotech industry. And that's a great way of closing the 4 main topics of today's session on garbage in, garbage out, and how to contextualize data, right, for AI readiness. So we have one final poll question for the audience. So please take 30 seconds to respond, and we'll, of course, briefly discuss the results with you like the previous one. So the question is, which capability would most accelerate your AI for manufacturing initiatives? Is it real-time data validation at the edge? Perhaps automated data contextualization? Operator-friendly data capture tools? Maybe unified data governance framework? Or spatial location-aware data integration? So submit your response. We will gladly discuss the results. So waiting for the results, just a few seconds. Thank you all for participating and for providing your answer to this question, very important. Whoa, here we see that there are two categories that are kind of front runners: automated data contextualization and real-time data validation at the edge. Probably Doc or Romina, would you like to comment on these results? You were expecting something different?
Yeah, I was expecting something different, to be honest, because, well, I can see that depending on maybe the industry or the organization, the problem is different, no? Because we don't have a clear winner here. We just see that depending on what the organization are we talking about, then it's a different problem. Obviously, data contextualization is the winner here, but it is not the only one. So we all have different problems, and we need to focus on we don't have the one recipe or the single recipe that is going to solve everything. So we need just to focus on what we are lacking, what we need to solve. So it's not a magical answer for this.
Yeah, absolutely. Doc, anything to add?
Yeah.
From your end?
Yeah, from my side, I mean, we've seen this before, right? I mean, when GPS first came about, everyone thought of it as a hiking tracker, right? That's all it ever was for the average person, and we had to build the market, right? And so as it proliferated and became useful, people adopted it. We saw the value it produced in data and in synchronization and how the world runs. Mm-hmm. So especially today, I mean, we've never really had a really high accuracy, ubiquitous technology that can validate every step on the floor. And it's no surprise that the main use case for it is error proofing, right? Literally detecting if the right bolts are being done up, if the welds are being completed properly, and, eliminating inspection. But as the value and the market is built, we'll definitely see the answer to this question change, and as AI matures and it's ready to accept this type of data.
Absolutely. Thanks, Romina and Doc, for sharing your insights on this second point question. And now it's time for the Q&A session. Try to answer questions from the audience. I see several, quite a few of them in the chat window. So let us get to as many as we can, right? So first question, this one is from Rashid Kokar. He's asking, what strategies or architectures have you seen work best for making industrial data decision-ready without overloading teams with extra processes? Anyone who would like to take this question?
So
go ahead, please.
Yeah, I can start, and I'm sure you have additional thoughts. I think from my perspective, a really good data structure and a really good digital ecosystem should allow us to use the systems that are optimized for the end users, collecting what we need and what they need to do their work, and everything in terms of harmonization, everything in terms of how to connect the information between the different data flows happening in a mature digital architecture, right? So for example, when it comes to the contextualization of the data, using tools that allow us to collect the data that are providing the context automatically really helps us to reduce the effort for the end users, which of course is what we need to do. Just as an example, the unit operations and the processes, right? So if we have the possibility to define them in one way or the other, the operator doesn't have to make additional aspects, but we can provide the context layer of unit operation. If we can connect a unit of measures and different aspects of our process that we know belong together, the operator doesn't have to provide this information. If we have the possibility to use tools to find our hidden contextualization and hidden interdependencies that we are not aware of, the operators and end users don't have to take care of that. So I think it's really optimizing the tools and rethinking them in a way from how have we used them over the last 30 years and how do we want to use them now that we are in the age of AI. I think, to me, that is a strategic decision.
Thanks, Judith.
Yeah, exactly. One of the approach is to apply AI at the moment to do this, to do the job for the operators as a co-pilot or a co-operator, we call it. For example, at the moment, we are working with some clients to build some AI agents to kind of pre-process the data and adding the context to that. We call it data processing context or digital twin agentic, where, I mean, of course, all operators are super busy with daily jobs, but you could assign this job to AI agents who knows the context, for example, knowing the context of the digital twin and mapping the Modbus data to the industrial semantic data for decision making. That would be one solution which will be applied very heavy in the future in the industries.
Thank you, Amit. Thanks for answering that. Oh, sorry.
Yeah. I just wanted to add that something important here is that we don't want to add extra work to the operators. So that's why we need to have all these solutions embedded in what they are already doing. So the tools need to be easy to use. So if we want to get information from them, or we want them to start using this information, it needs to happen in the real time. So when they are working on something, no? So when they need this information to add value to them. So having the right tools, easy tools, in the moment that they are using them, the same tools, not adding extra things for them, because if they need to close something, open something else, and to review or to add information, that is going to be a barrier for the adoption or for adding value to what they are currently doing.
Thanks, Romina. And it's great to see that everyone is sharing their insights and opinions on that question. Doc, do you have anything to add on this question?
No, I think everyone else answered the question very well. Thank you.
Absolutely. And we'll tackle one more question really quick because we are approaching the end of the session. It's more like a problem description, and then if we agree with that approach, right? This is a question from Yannick. He says, Previously, the strategy was to pump all raw industrial data into the data lake so that smart people could generate insights from it, right? This strategy failed because we forgot that domain knowledge is needed to contextualize data. Data must be contextualized as quickly as possible and at the level at which it is created. So there's a problem here. Contextualization is expensive and doesn't generate a direct return on investment. Would you agree with this approach, with this statement? Anyone who would like to add his thoughts or her thoughts here?
So I would say I 100% agree with that statement if we don't connect the contextualization with a direct outcome, right? So I think from a strategy point of view, connecting it to a specific use case can create a return on invest. While I 100% agree, and I see that very often when we get into this discussion, that people don't want to spend too much time on it because there is no direct outcome. So we need to connect it to a direct outcome and a direct return on invest in order to get this done and in order to get more companies to adopt it and to really fulfill the potential. So I fully agree to the statement, and I think that is a task to us to create a return on investment.
Thank you so much, Judith. Sorry?
Very shortly, that's a very, very good observation about our today situation in industry. However, in the future, this thing is going to be completely changed. I mean, we had already data scientists, and now in the future, AI agents will take care of this. So the context will be added in real time by AI agents, and the data should not be laid off there in data lakes for data scientists. So a big shift is going to happen about this question.
Absolutely, and I personally agree that with a specific use case and application, if you establish a data layer foundation, the foundational data layer, and you add on top of that an industrial AI technology within a specific use case or application, you will see a return on investment sooner than later, right? So we're on time. I'd like to say a few closing thoughts. On one hand, thank you very much to our panelists, Romina, Judith, Douglas, and Omid, for sharing your insights and expertise. This was a fantastic discussion and, more important, an engaging learning experience. Thank you again to Atelic, our session sponsor. Your support makes this content possible. And thank you very, very much to everyone in the audience for joining us and for your thought-provoking questions. The next session is Building Data Infrastructure for Predictive Operations. I encourage you to stay and keep learning from industry experts and leaders in their fields. Have a wonderful day ahead and enjoy the rest of Manufacturing and Supply Chain Day 2025. Thank you very much.
Thanks for having us.
Thank you.
Thank you, everybody.
Have a good day. Bye.
Have a good day. Thank you so much.